Hey guys, so I am not here today, so here are the notes. I'll watch through the video and then you'll have a worksheet afterwards. So make sure your notebook is out and you're taking these notes and putting them in your notebook. So we are going to be covering chapter 3, section 5 today, and our essential question is, how can I graph slope-intercept form? So slope-intercept form is the form that we use the majority of the time when we're graphing lines. So we're going to be talking about how to find our slope-intercept form if we're given certain information. So first thing, the main part of today is actually going to be covering slope and how to find your slope. So we know that slope is equal to the variable m. It's always equal to m. M stands for slope. And our slope is always our rise over our run, which is the change in y over the change in x. And we always use this little equation if we have 2 points and we want to find the slope of them. y2 minus y1 divided by x2 minus x1. So depending on your problem will depend on which piece of this you use. If you're given a graph, typically you use the rise over the run piece, and then if you're given 2 points, you're going to use this y2 minus y1 over x2 minus x1. I'm going to give you a minute or so to write that down so that you have it, and we'll move on. So next thing that we have is if we're given a graph. So here's this graph here. We have our x is always our horizontal axis, our y is our vertical axis, and then we just have some sort of line. I didn't want it to line up on my intersection points because these are just generic points. I don't know exactly where they're at. So in this point over here on the left, I labeled it as x1, comma y1. This point on the right is labeled as x2, comma y2. And then my run goes horizontal, and it's taking my x2 minus my x1, and then my rise is going up and down. Mine happens to go up on this one, and that's my y2 minus y1. So I have it all color-coded, so my rise is all pink and my run is all green. So go ahead and get that written down. Next, I want to make sure that we have our information about our different types of slope. Pretty sure that we did cover this already, but I want to make sure it's in this section so it's easy for us to find. Just grabbing my pens real quick, hold on. So first thing that we have is that if our graph goes up towards the right, we know it's going to be a positive slope. So when we're talking about slope, it's always fraction form, which means it's going to be a positive over a positive or a negative number over a negative number. Those are our two options to get this positive overall slope. Option number 2 is we could have a negative slope. So that one is going down to the right, and this is a negative slope. And our two ways that we can get that is if we have a positive over a negative or a negative over a positive. Next are kind of our trickier ones. So we have our slope of 0. So this is where we have a horizontal line, has a slope of 0, and that's when we have 0 over any positive number or 0 over any negative number. Gives us a slope of 0. And then our last option is this undefined slope, where we have this vertical line. So it's going to be a number divided by 0 or a number divided by 0, positive or negative, it doesn't matter. So positive, we're going uphill, negative, we're going downhill, 0 is just flat, and undefined, we fall down. These are our 4 types of slope. So in our first example, you're going to have to figure out what type of slope do you have, and then once you find out what type of slope you have, you're going to have to determine what is that slope. So I want to make sure I give you enough time to copy these 4 different types of slopes down, and then we'll move to our first example. Okay. So I want you to describe the slope of each line and find the slope for each line. So if I want to describe the slope for graph A, first thing I'm going to do is I'm going to give you just a minute so that you can copy this graph down. So we have this point over here is at -3, -2, and then this point over here is at +3, +2. So put example 1A, copy this graph down. So the very first thing I want to do is I want to decide what type of slope I have, whether it's a positive, negative, 0, or undefined. Since this is going up to the right, I know this is going to be a positive slope. Now my goal is to figure out, well, what actually is the slope? So in order to do that, we want to build what we call a slope triangle. So I'm going to start at one of my points, and I'm going to go straight up until I get even with my other point. So I'm going up here, and I'm going to count how many I have to go. I have to go 1, 2, 3, 4, and since I'm going up, that's a positive. Now I'm going to do my run, because that was my rise. So my run, I'm going to finish off my triangle, and I'm going to count how many I have to go over. 1, 2, 3, 4, 5, 6. And since I'm going to the right, that is a positive 6. So we know that our slope is our rise over our run. So in this particular case, we rose 4, and we went for a run of 6. Now, since this is a fraction, we have to reduce it if we can, and 4 and 6 have a common number of 2, so our final slope is going to be 2 over 3. And there is the slope of our line. It's positive, and it's 2/3. We go up 2 and over 3, up 2 and over 3. So I want you to try B. So on B, we have this point of 0, 2. Right here, we have the point 2, -1. So first I want you to decide what kind of slope do you have. After you decide what kind of slope you have, I want you to actually find your slope using your slope triangle. Remember, if you go up, it's positive, down is negative, to the right is positive, and to the left is negative. I'm giving you a little bit of a chance to figure it out on your own before we go over it. Remember, when you're finding slope, you always have to reduce your fraction if you can, but leave it as a fraction. Don't change it to a mixed number. Don't change it to or leave it as an improper fraction. If it is, don't give me a decimal. So first thing I want to do is I want to decide what type of slope I have. Since it's starting at the top left and going down to the right, it's going downhill, which means it's a negative slope. So now I'm going to do my rise and run. So my rise is actually going down, and I go down 1, 2, 3, so that's -3. For my run, I'm going over 1, 2 to the right, so that's a +2. So my slope is rise. Oops, let me keep this color coded here. Rise over run, and we rose a -3, and we ran a +2. So our slope is -3 over +2 is our slope. It's a negative value. Just make sure you have this all written down. Hopefully, if I give you a graph, it's a little easier to figure out what your slope is now. I would probably put right here that up is positive, down is negative, right is positive, and left is negative. And I would highlight that because that's a very important point. Okay, let's move on to the next problem. So example 2 says, the table represents points on a line. How do you find the slope? What is the slope? So if we're given this table here, in order to find our slope, we are going to use our slope formula equation. So our very first step is we need to figure out what our 2 points that we want to use are. So it gives us 4 points. It gives us the top one, second, third, and fourth, and we can pick whichever 2 points we want. It doesn't matter which ones you pick. So I'm just going to pick the first one, 420, and the second one, 7, 14. So now our slope formula was m equals y2 minus y1 over x2 minus x1. So our y's are on top and our x's are on bottom. And it doesn't matter which point you make your y1 and y2 and x1 and x2, as long as you have a x and a y together. So I'm going to make my first one my 1's, and then my second point my 2's. So here's what we have. We have 4 is x1, 20 is y1, 7 is x2, and 14 is y2. So I'm just going to replace all of my numbers. So y2 I'm going to replace with 14 minus y1 is 20 over x2, which is 7, minus x1, which is 4. So I replaced all of my letters, my x's and my y's, with numbers. Now I'm just going to work across the top. So 14 minus 20 gives us a -6. And 7 minus 4 gives us a 3. So on the top we got -6. On the bottom we got 3. And -6 over 3 can reduce to -2 over 1, which is -2. So our slope is -2. I'm going to give you a minute to get this written down, because we're going to be using this formula of this y2 minus y1 over x2 minus x1 a lot. So I want to make sure that you have it written down so you can refer to it. Okay, so I want you to try part B. We have x is -1, 1, 3, 5. Y is 2, 2, 2, 2. So pick any 2 points. It doesn't matter which one you pick. You're going to pick 2 of them. So I just always pick the first 2 just because it's easy to remember. So I have -1, comma 2. And then we have 1, comma 2. So now I want to decide which are my x1 and y1, and my x2 and my y2. So I'm going to plug into my formula. M equals y2 minus y1 over x2 minus x1. So I decided that my y2 was going to be my 2. My y1 is 2. And my x2 is 1. My x1 is 1. So when I plug it in, I have this. And the reason I wrote it like this is because my equation has a negative in it. And then my x1 is also negative. But we know that 2 negatives make a positive. So on the top I have 2 minus 2, which is 0. On the bottom I really am saying that I have 1 plus 1. And 1 plus 1 is 2. Well, on the front page, we said that if we have 0 divided by any number, that is equal to 0. So our slope is 0. Okay, part C. What I want you to try is x is -3, -3, -3, -3. Y is -3, 0, 6, and 9. So I'm going to give you just a minute to figure out what 2 points you want to use. Write them down. Label them as x1, y1, x2, and y2. Then plug them into m equals y2 minus y1 over x2 minus x1. Like I said, I like to pick the first 2 points, so I'm going to do -3, -3, and -3, 0. So I have my x1, y1, x2, y2. So we have m is equal to y2 minus y1 over x2 minus x1. So I'm going to replace my letters. So y2 I said was 0. Y1 is -3, so I have that funky little minus a negative again this time. Sorry about that. Got interrupted for a second. But now I'm back. Okay. So it has this funky minus a negative. And then for my x's, my x2 is -3 minus my x1 is also -3. So I have another minus a negative. So we know that these actually make a positive. So I have 0 plus 3 over these two make a positive -3 plus 3. Well, 0 plus 3 is 3, and -3 plus 3 is 0. I can't divide by 0, so my answer is undefined. And if you put that into your calculator, it's going to say error. Syntax error, probably. So this is undefined. Okay, so now what we have is we have our slope-intercept form. So this is our slope-intercept form. We're kind of familiar with it. We've seen it a couple times already. It is y equals mx plus b. So m stands for slope, and b stands for y-intercept, and this is always at the location of 0, b. It's on our y-axis. Where is the line crossing the y-axis? We just got done talking about slope, so I'm not going to spend too much time referring to the slope. Okay. So what we're going to do is we are going to be looking at different equations. We're going to have to come up with the slope and the y-intercept for each equation. So our first equation here, number 3, says find the slope and the y-intercept of each equation. So A says y equals 3x minus 4. Now since this is already in slope-intercept form, we know that this here is our slope and this is our y-intercept. So m is equal to 3 and b is equal to -4, and I have to bring that negative that's with my in front of my 4 with it when I write it in my slope-intercept form, or when I write my y-intercept. Pretty easy for this because you just pull it out. Slope is your first number, y-intercept is your second number. Slope is always attached to x because x is our independent variable, and so it's always going to be changing. So B is a little more difficult. This time we have y equals 6.5. Now I have to rearrange this so it's in the form of y equals mx plus b. Well, I don't even have an x on here at all. There's no x in this equation. So I know the only way to get an x to go away is to multiply it by 0. So I can rewrite this equation as y equals 0x plus 6.5 is how I could rewrite this equation. So now I can see what my y-intercept and my slope is. My slope is this guy here. This is 0 is my slope. 6.5 is my y-intercept. I'm going to write that off to the side, that m is equal to 0 and b is equal to 6.5. So the last problem that we're going to look at today is part C. So if we look here at C, this one looks kind of funky. So we have -5x minus y is equal to -2. Well, our ultimate goal before we can find our answer is we need it to be in this form of slope-intercept form, which means I need to get my y all by itself. So I need to isolate this y. Now we talked about this when we were solving our literal equations on how to go about this. So hopefully, I know it's been a while, hopefully you remember. So first thing we have to do is we have to move this -5x to the other side of the equation. So we have a -5x, which means I want the opposite of minusing 5x, so we're going to add 5x to both sides. Now when we add 5x to both sides, I can't combine a -2 and a 5x because they're not like terms. So I have this -y, I have to bring that negative that's in front of my y down, equals, and since I want it in y equals mx plus b form, I'm going to put the 5x and then minus 2. So it's kind of making that form for me. Now I don't want a negative y, so we've talked a lot about how to get that negative y to go away. We divide every piece by negative 1. So my negatives cancel out here, which gives me a y equals negative 5 divided by negative 1 is negative 5x. And negative 2 divided by negative 1 gives us a positive 2. That changes all of our signs. So now we have our slope and our y-intercept. So our slope is negative 5. Our y-intercept is positive 2. So if I come over here, I'm going to write m equals negative 5 and b equals 2. And there's my answer. So on your worksheet, it's going to give you a graph. You're going to have to find the slope from a graph. It's going to give you 2 points. If it gives you 2 points, you're going to use this like what we did on these 3, where you plug into the y1 minus y, or y2 minus y1 over x2 minus x1. And then it's also going to give you some equations, and you're going to have to figure out what your slope and your y-intercept are from your equations. Those are the 3 types of problems that you're going to have on your worksheet today. We will be finishing this section on Monday, so make sure that you have all of these written down so that you can use them. Have a great weekend.